So back when we were talking about derivatives, we talked about the mean value theorem and finding the average rate of change over an interval, and how if the function was continuous and differentiable over that interval, that there was at least one x-coordinate inside that interval where the tangent line slope was equal to the secant line slope, right? But you can actually, there's a mean value theorem for integrals as well. Some people call this mean value theorem for integrals. It's often referred to as just average value of function. Sometimes you'll also see it referred to as the MVT2, the second mean value theorem, whatever you want to say. But what this theorem says is that if f of x is continuous on a closed interval from a to b, ooh, those are bad brackets. Okay, let's try that again. Right, then there exists a c in the open interval from a to b. So we're not including the endpoints here. So there's an x value, a c value in between the starting and stopping point a and b, such that f of c is equal to 1 over b minus a times the definite integral from a to b of f of x dx. And what this is, right, this expression over here, that is what we refer to as the average value of the function over that interval. So visually what that means is if we have this function and we're going from a to b, right? So say we have that function, right? So when we're taking the definite integral, right, since my example here is all positive, what we're really doing is just finding the area under the curve. What the average value of a function does, or what this mean value theorem for integrals does visually, is it creates, like say your f of c is here. We still have a and b. I didn't draw these very proportionally, so it's a little hard to visualize. But so all the average value of a function is doing is saying that there is a c value, an x value, somewhere in between these two starting and stopping points, where the height there, if you created a rectangle, would have the same area as the area under the curve between the whole thing. So essentially, you're just creating a rectangle that has the same area as the definite integral from a to b, where that f of c, that height, is the height of the rectangle. So that c value that you're finding is really telling you how to find the height of the rectangle, to find the average value. So average value is really just, can you take this curvy shape that you're finding the area under, and can you squish it down into a rectangle? That's all we're doing. So we're going to do a couple of examples. So the first thing we're going to do is we're going to find the average value for f of x equaling 3x squared minus 2x on the interval from 1 to 4, and then we're going to find the c value. So two parts here. So the first thing we're going to do is say, okay, well, the average value is equal to 1 over b minus a, so 4 minus 1, times the integral from 1 to 4 of my function. So I'm going to get 1/3 times, if I integrate on the inside, I'm going to get x cubed minus x squared, evaluated from 1 to 4. So if I plug in 4, I get 64 minus 16 minus 1, so those are going to cancel out. And then 64 minus 16 is 48, and 48 divided by 3 is 16. So the average value of my function here is 16. So that tells me my f of c is equal to 16. So the height of my rectangle, in other words, is 16. And then if we set that equal to the function, So if I want to know where C is, that means that 3C squared minus 2C is equal to 16. So 3C squared minus 2C minus 16 equals 0. Now, I'm going to just show you how I factor. So if you multiply A and C, you get negative 48, and you want to add up to negative 2, that's negative 8 and positive 6. So because 3C squared, 3 is prime, I know this has to be 3C and C, and the only way to get a 6 is to do 3 times 2, and it's positive 6, so it's a positive 2, and then I want a negative 8, because negative 8 times 2 is negative 16, and negative 8 times C will give me negative 8C. So this tells me that C can equal 8/3, or C can equal negative 2. Now 8/3 is a little bit more than 2, so that's inside my interval, but this one is not, so my answer is going to be C is 8/3.